In this video, we're going to look at the topics of class variables and methods. Up to this point, our focus has really been on the idea of instance variables and methods. So just as a reminder of what an instance variable is, the fields that we define at the beginning of a class mean that each instance of that class will have its own independent copy of those variables. So for instance, in the ticket machine class, we defined a field called price, and every time we created a ticket machine object, the price field was set appropriate for that particular instance. So typically we see the initialization of instance variables via the constructor of the class. In contrast, the kind of variables we want to talk about now are called class variables, and the idea is that rather than belonging to individual instances, class variables belong to the class. In other words, a single variable is shared amongst all instances of that class. And in fact, class variables exist independent of any instances. So a class variable can exist even if we haven't defined any instances of the class that contains it. We recognize a class variable because it has the word static in its declaration. So in the auction project, for instance, we defined a static variable called next lot number. And the idea was that as each lot is created, it acquires a unique number, and the number is acquired from the class. And each time a new lot is created, the next lot number value is incremented, so that the next time another lot is created, it's the updated value that gets used. So the next lot number belongs to the class, and each instance then gets to record what the current value of that class variable is in order to identify it. Let's look at a particular example. Here we've got the idea of a program that's going to model bouncing balls, and we're going to simulate the effect of gravity on those balls. Now the effect of gravity is going to be the same on every single ball that we create. So we don't really need to have an instance variable defined inside the bouncing ball class that records what the current value of the gravity is, because the gravity is going to be fixed and it's going to be the same for all balls. Therefore, we define the gravity variable as a class variable inside the bouncing ball class, and then each instance can refer to that fixed value, and all balls will see the same value because that variable is shared between them. Let's look at the program in practice just to see how that effect works. Here's the bouncing ball project, and here's the source code. So we see some definitions at the start of the bouncing ball class of typical instance variables defining things like how fast the ball is dropping, what its position is, how big the ball is. But right at the top we see a definition of a variable called gravity, whose value is set to 3, and that uses the word static. Note we've also got the word final here, and we'll be discussing later in the video what final means. Static and final are independent concepts, so we'll cover that separately. But the idea here is that because the gravity variable has been defined to be static, then each time a bouncing ball instance is created, we don't get a new copy of the gravity variable. There's one copy, it's actually defined inside the class, but all bouncing ball instances can gain access to its value. So let's see the program in action. The ball demo drops a couple of different sized balls from the sky, and the effect of gravity adjusts their speed as they fall, they increase in speed as they fall, and then gravity acts as a resistance as they bounce on the ground. Now, it's important to appreciate that class variables are a specialism of variables. So we don't want to now consider all variables that we define inside classes as being candidates for being static variables. Typically, a class will define instance variables that are non-static, but from time to time we'll define a class where the instances wish to share information, and they can do that via a class variable. So in the bouncing ball class, we noted that we'd also defined the gravity static variable as being final. We use the word final when the value that's been assigned to a variable is to remain that variable's value throughout that variable's existence. So throughout the existence of the bouncing ball program, gravity was not going to change. So it made sense to actually define the variable as being final as well as being static. By using the word final, we actually give an indication to the programmer that, having noted the value of a variable, they know it's not going to change, and they can factor that into their understanding of program code as they're reading it. It also acts as a safety net. If we know that the value of a variable shouldn't be changed once it's been set, then any code that attempts to change that variable will be trapped by the compiler, because the compiler knows that the variable's value must not be changed. So it's both a documentation aid and a programming safety aid. The final bullet point on the slide makes the point that if we know that a variable's value cannot be changed, then in some circumstances it can be appropriate to define an instance variable as being public rather than private, because the variable is prevented from outside interference by objects of other classes by the fact that its value has been set once it's been defined. However, that's a relatively minor point, but we will see the use of public and final in some of the further examples, particularly in the context where we combine both static and final. So as we saw in the bouncing ball class, it is sometimes common to combine both static and final, although it must be stressed that those two concepts are independent. They have no direct relationship to each other. Now, one of the situations in which we might use static and final and also public visibility is when we wish a class to, in effect, be the place where we define constant values that are going to be generally accessible throughout a program. So you can imagine a program that's concerned with monitoring temperatures in an application as wishing to give symbolic names to particularly significant temperatures, things like the boiling point of water, and that value will be fixed, but we want that value to be used in multiple classes. So rather than having an instance field with an accessor method, we will often define that sort of variable as being public, static, and final. Public, so it's accessible widely throughout the program. Static, because we don't want it to belong to individual instances, it's a shared value. And final, because its value is going to remain constant. It's not something to be varied as the program runs. So for instance, public, static, final, int, or potentially double, boiling point is the value 100, might then be used in a program monitoring temperatures in a system. Now, just as we can have static variables that belong to a class rather than its instances, we can define static methods that have the same characteristics. So static methods belong to the class rather than to instances, and therefore static methods are invoked by using the class name immediately preceding them. Now, usually it would be an error to try to call a method using the name of a class rather than the name of the instance. And you might often come across a compiler error message that tells you that you're trying to invoke a non-static method. And that's an indication that you've probably used the class name rather than an instance variable name. A static method is invoked in exactly that way, class name dot method name. Now, what a static method tells us is that this method requires no instance state. The method acts independently of any instances. It can only access static elements within the class definition. A well-known static method that is often used for things like timing how long it takes to execute a piece of a program is the current time millis method of the java.lang.system class. And so we invoke it by saying system.currentTime millis, and it returns us the number of milliseconds since the 1st of January 1970. So static methods exist independent of any instances. They are not allowed to access any instance fields that might be defined within their class, and they are also not allowed to make any internal method calls to non-static methods, again defined within their class. There's one particular static method that every Java programmer really needs to know about, and that is the static method called main that has this particular form. So every Java program that's being run anywhere other than within BlueJ must have a method that looks like this in order to be able to run. So the method must be public, it must be static, it has a void return type, and it takes a parameter of type array of string. So if we want to run a program, we have to create a class with a static main method that looks like this, and then inside the body of the method we define all the steps required to get the program up and running. So this is the starting point for all Java programs. So the main method must be public, it must be static, it must have an array of strings as a parameter. What that parameter provides is a way for extra information to be passed into a program from the outside world. So it supports runtime configuration. Often that array contains no strings. If we don't require any information to come in from the outside, that array will have a 0 length. But if we want to provide information, then that's the way that we do that. So for instance, we might write a program that's to check for differences between two files. Typically we will name the two files to be compared when we run the program, and those two file names would be passed in via this array of string parameter. The alternative, of course, would be to have the program run interactively and for the program to prompt the user to type the names of the two files. But that would be a less common and less flexible way of providing the input information that the program requires to make the comparison. So the parameter is there for runtime configuration. So here's a very simple example where we have a main method that's designed to create an instance of the game class and then invoke the game's play method. So the main method is getting the program up and running right at the start. So to review what we've covered in this video, we've seen that class variables belong to their class rather than any individual instances, and therefore only one copy of a class variable exists within a program, and it exists within the class. We've also seen that we can define methods as being static, which means that they are class method, and once again they belong to the class, they're not part of individual instances, and therefore we invoke static methods by writing class name dot and then the method name. Class variables provide a means to share common data amongst all the instances of that class should that be necessary, and we've also seen that class variables are often used to provide global information to a program, particularly where static is combined with public and final. We've looked at the keyword final, and we've said that when a variable is designated as final, its value is fixed from the point of initialization. And any final instance variables must be initialized either at the point of declaration or within the constructor of the class. And the compiler will check to make sure that those rules are being followed.